Hi, my name is Mike Lawrence. This video is one of a set which is intended to provide a different interpretation of the experimental results that constitute the foundation of current physics. It is clear that the present explanation for what we see in the universe is good in many ways, but it is missing an overall coherence. My view is that we need to look at physics with new eyes and consider an interpretation that explains most things well, even if it does question just about everything. I do not disagree with any experimental results, only the interpretation of those results. And I do not say that the hypothesis that I'll be talking about in these videos is the theory of everything, and that everything I suggest is correct, but it is a start. Each video in the set will cover an aspect of physics. The whole set needs to be understood together in combination, because many aspects rely on each other, and any one taken on its own may not be convincing to those relying on the current interpretations, some of whom may actually be offended by the hypothesis. There will be links in the videos to other videos in the set that cover closely related or overlapping aspects. Within the boxes in the videos are representations of the motions of the particles and their composites, which I will be explaining more fully. I'm happy to answer questions where I can, perhaps providing links to where a deeper mathematical analysis shows why I say what I do, since equations and graphs do not make good videos, and will post replies where appropriate on Twitter. I hope you enjoy the videos and they enable you to better appreciate the absolute symmetry and simplicity of nature. But please remember, I'm not an experienced presenter, and although I state everything as if it were correct, this is only a hypothesis. This is video number 4. What size was our inflation? My interpretation of inflation is the increase in size of loops from the formation in our Big Bang at around the adjusted Planck energy, meaning a radius of around 1 adjusted Planck distance, to their current size. Since our fermions have different masses, they have different loop radii, and so the inflation rate must have been different for each fermion across the 3 families. The hypothesis is that, with our 3 physical dimensions, the inflation amount along each dimension was different. The inflation event will have locked the loops into one of the 3 planes formed by those 3 stretches. So with 3 fermion families, 3 inflation planes, and 4 different loop charges, there will be 12 different masses in our Big Bang. Other Big Bangs, randomly occurring throughout the universe, will have their own inflation rates, so will have different fermion-equivalent loop sizes, even if they have the same 3 meon pairs in each loop. To take the electron as the maximum inflation effect along one of the 3 spatial planes, since it is the smallest mass but largest radius fermion, it will have inflated to its current size of 9 times 10 to the minus 31 kilograms, which is a radius of 3 times 10 to the minus 21 meters, or in double adjusted SI units, 7 times 10 to the 8, meaning the inflation plane for the electron is inflated by about 700 million times. Like all single loops, the electron has that inflated size locked in and takes frequency from interacting photons to replace the energy it loses to the background viscosity. Different Big Bangs will result in exactly the same environment as we already have, with exactly the same laws of physics and loop structures as their composite forms. However, depending on the inflation rates, each Big Bang would have different loop sizes, meaning masses, and so different chemistry and emission absorption spectra, even if the loops formed have our 3-pair number. Related videos would be 5, why there is only one universe and many Big Bangs, and 16, why fermion masses are proportional to their charges. Thank you for watching.